Hi, everybody. So you'll notice that we're doing meteorology at 101 today. Usually I start off the whole section on Asia by talking about this, but this just fit really well for a Friday class on your own as opposed to the Japan where we could sort of meet together. So that's why we're doing this. The point that I want to make today is not that you're going to be an expert on weather. That's what meteorology is, obviously. But that you're going to understand how important just a few basic ideas about weather are in, well, really all over the world, but particularly in Asia as we get to this. So let's get after it. But before I do, I just want to keep this in mind. It's not that we're learning weather because we want to be, understand the weather and talk to people who watch the Weather Channel or anything like that. We want to understand weather because weather is really important to the ability to grow food. And food is really important to demographics and other things like that. And as we'll see as we go through both stuff for today and collateral readings and all that, you'll see that weather has a big impact on a bunch of other areas. Particularly at the end, you'll sort of see how it is not even though we would say the rain falls on everybody, it definitely falls harder on the poor. So these all play a role in this. Okay, let's get after it. So we're going to start with terminology. So the first thing I want to point out is this thing called a monsoon. So a monsoon is going to be the big thing we talk about really today. The monsoon is not the storm. I want to be clear about this. If I say anything clear, write this down. Monsoon is not the storm. The monsoon is the seasonal reversal of wind direction, which can carry storms, but it's not the storm. Does that make sense? Yeah. So essentially, there are pretty predictable patterns of wind direction, and that's going to be fairly important. So it's not the storms, it's not the rain, it's the winds that bring the rain or don't. So actually, you could have, I don't know if you remember this or not, but last week, at least in California, it was super hot in California and dry. The wind was blowing from Arizona over San Diego and California, and it was just super hot and dry. That's a monsoon. It's not that it's wet, it's not that it's the storm, it's the seasonal reversal of wind direction. Okay. Obviously, it's important for agriculture because this is where the rain is coming from for a lot of places in the water, and so it's going to be incredibly important for how much you can grow, what you can grow, if there's too much water, how little you can grow, all that kind of stuff. It's also important for sea trade historically. If you study, if you do World Civ or classes like that, you'll note that historically, before we got steam power or coal or now gas and other things like that, if you're going to get anywhere, you needed to follow the wind. And so the seasonal reversal was just incredibly important for how trade happened and how even cultures interacted, et cetera, et cetera. So then we can talk about what storms are on those winds, on those monsoons. And there are some big storms. Like, for example, the easiest thing to think about is in the United States, every year we talk about hurricanes hitting. Hurricane Sally just hit a little bit ago. Hurricanes are big storms in the Western Hemisphere. So theoretically, if a hurricane hit California, or if a big storm hit California, we call that a hurricane. In Northwest Pacific Ocean, meaning Japan, Korea, and northern China, they call it a typhoon. And if it is a big storm that is from the Indian Ocean and the Southwest Pacific, so largely hitting, Bangladesh, India, Pakistan, they call that a cyclone. The important thing to remember is all three of these things are the same exact thing. The only difference is where they are. That's it. So essentially, if you hear that there's a typhoon about to hit Japan, you can just sort of in your head mentally picture a hurricane. It's the same exact thing. Okay, so we got our terms here. We've got these big storms, which are dependent on where you're at rather than anything about those storms themselves. And then we know these storms are carried on winds, which the monsoons are these seasonal reversals of wind direction. So let's talk about monsoons in South Asia. I have a map on the next page, so for now just sort of work with me on the science and we'll do the map. So let's start with the summer monsoon. The summer monsoon in India, let's just focus on India for a second, is the rainy season. And let's just talk about what that means and how we know this. If you've ever been to India in the summer, you know that it's warm, but it's wet. So let's start with, it's really hot. In the summer, it's summertime, it's going to be hot. And it's hot in the Great Thar Desert, which is kind of a little chunk in the northwest part of India. And it's hot up in Tibet, up in the Himalayas. So it's hot in those areas, or I should say relatively hot. Where you have heat, you have low pressure. So essentially, here's a way to think about this. Let's say that I've got this area here, and I've got all these little air particles in here. Okay, these are air particles. And as it heats up, the air particles start moving around a lot more. And that means that they need more room to move. And so it kind of pushes out some of these particles to the point where the hotter it is, the fewer particles you're going to have in this area. Not that you need to know the science on this or anything like that, but it's going to help sort of understand. So if hot equals low pressure, which gets really confusing sometimes, because sometimes you'll see on a map, low pressure system or high pressure system, and they'll represent it like a low pressure system, or let's say a high pressure system, and you might think, oh, that means it's hot. No, it means it's cold, actually. So hot equals low pressure. Okay, so now let's talk about something that is, sometimes when you just think about these things, they kind of blow your mind a little bit. I'm not trying to blow your mind, but let's just see how this works. So let's look down here at these glasses down here. So I got two glasses sitting next to each other. One is a glass that has got clear water in it. The other glass has red food coloring in it. That's what all the dots are, red food coloring. Okay? So now let's say that I magically create a tube and connect these two different systems. What's going to happen with the food coloring? Exactly, the food coloring is going to move through here, and it's going to come over to here to the point where there's going to be less over here and more over here, and it'll sort of stabilize at even amounts of food coloring on both sides, right? But essentially what we see is a flow of the food coloring that direction. Now, here's the thing that I want to sort of blow your mind a little bit. Air moves from high pressure areas to low pressure areas. There's a lot, so in our sort of system here, we would say there's a lot of air particles on this side, and there's very few on this side, and then I connect them, and these particles here, trying to get space, they start moving over this way. We call this wind. That's all wind is. Wind is just the movement of air particles, and it's nothing really fancy other than that. It's just air moving from a high pressure area to a low pressure area. So if we can sort of look at this on a grand scale, we can sort of predict a lot of things about what's going on. Now, given this, let's just talk about our monsoon for a second. So let's just say here's India. So up here it's hot, which means it's a low pressure area. And relatively speaking, it doesn't mean it's going to be cold, but it's going to be cooler out here over the water. Call that a high pressure system. Okay, so now what do we expect is going to happen? We expect that air is going to flow from high pressure to low pressure, so air is going to flow like this. And the air is going to start over the water and move inland. So this air over the water is moist air. This is where you get clouds and all that kind of stuff. And as the wind takes it, it's going to move inland, and it's going to drop the water in here, and you're going to get the rainy season in India and Pakistan. It's really, I'm making it sound probably more complicated than it actually is. This is really just all that's going on here. As it hits mountains here, it's going to drop even more water. And so during the summer, we just know there's going to be a rainy season. That's just because that's sort of how the pressure, air pressure, and all that works out. And the result is going to be lots and lots of rain. That's it. You got monsoons. You got the whole thing. Honestly, everything that we're going to talk about from now on is really just about variation in the monsoons, but that's the whole gist right there. So if we go to our map, we can see again this sort of red, that it's moving this direction over India. like that, over Pakistan over here. It doesn't really show that. Definitely going to move over Bangladesh. And this is our South Asia summer monsoon system. Now, not to sort of drag this out too much, but that's going to raise the question, what happens in the wintertime? The wintertime is what we call the dry season. And it's pretty simple if you just think about it. Everything just kind of flips because now it's cooler up in Tibet, relatively speaking, to the water. So it's cooler in Tibet, which means that the pressure is, if it's cooler, the pressure is going to be higher, and it's going to be relatively warmer over the water, which means the pressure is going to be lower. We know that air flows from high pressure to low pressure, which means the air is going to start, or the wind is going to start over the mountains and flow out to sea. The air that starts over the mountains is not moist. It's relatively dry. And so dry air from the mountains and desert moves towards the sea. And particularly here, when you have that right there, the wind is probably picking up some of that dust and dirt and actually spreading in a thing we call desertification, where essentially the desert grows. All right, that's that. You've got the whole basic thing. There's more to it than that, but this is enough to get you going. I'll just add one more thing. What about China? China's way over there on the other side. But the answer is really the same principle. If you know when things are warm and cool, you'll know the process. So it's really the same reasons and same seasons as India, because essentially Tibet, that Himalayan area, and the Gobi Desert, if you remember where the Gobi Desert is, those are essentially going to be warm in summer, draw the wind from the ocean over China, wet season, and they're going to be cooler in the winter. The air is going to start over those areas and go back over China and essentially be dry. So like I said, Gobi Desert is doing part of the work with Tibet on this. And so we have a very similar thing. We know that in the summertime in northern China and in India, Pakistan, Bangladesh, it's the rainy season. We know that in the wintertime, it's going to be the dry season in those areas. That's it. So I'm going to have you watch another video just to sort of drive some of these things home. It's NASA, so there's like astronauts telling you about things. It's not really astronauts, but NASA is going to sort of show you some pictures to sort of clarify this, solidify it in your mind, and we'll come back and talk about another set of monsoons.